The limit comparison test. The general idea is, once again, like the ratio test, we're going to take the limit as n approaches infinity. All right. What are we going to take that limit of? It's going to be the ratio of two positive series. Okay, so a sub n and b sub n, we're going to find the ratio, or rather the limit as n approaches infinity of the ratio. Assuming that that's equal to some positive number, then what we can tell from there is that either both series will converge or both series will diverge. So this is similar to the direct comparison test, all right, in that we are comparing a series which we are curious about with a series that we already know either converges or diverges. And it's also connected in a way sort of to the ratio test, where we're taking the limit as n approaches infinity. So there's a little bit of a merge factor going on right there. Okay. So what we want to do, basically, as you'll see in the next video with the examples, is that we want to really focus on series that we already know either converge or diverge. So what do those series happen to be? Well, quite often, not always, but let's use the harmonic series, which we know diverges, or any one of the p series which is going to converge. In other words, we have a p series where p is greater than 1. All right, so because we know that this diverges, if we take the limit as n approaches infinity, where this 1 over n is one of our two series, all right, and if we can get the limit to be equal to some number, well, then we know that our series that we're curious about is also going to diverge. All right, in the same token, if we have the ability to take a series which we know converges, and we find the limit of the ratio of our series with the unknown series, and we get a value, well, then our series that we're curious about, we know that that will converge. So that's the general idea. Take something you know, compare it, hence limit comparison test, using a limit to find out whether or not the series will converge or diverge.